Setting up the development environment overview. Hello learners. Before building applications with Django, it is crucial to set up your development environment correctly. In this tutorial, you will learn to install Python, Django, necessary packages on Windows, verifying the installations, and troubleshoot common issues. Step 1. Creating an environment with Anaconda. Open the Anaconda prompt as administrator for proper permissions. Use the following command to create a new environment with Django and Python. Conda create -n bj2, for example. Django. We choose yes. The environment created with the required packages. To activate created environment, we use conda. Activate dj2. Understanding installed packages. For example, Django 5.1, the main framework for building web application. ASGI Reef 3.8, PEP version 24.3, Python 3.13, SQL Pairs 4.5, TZ Data, SQLite 3.48, and other system libraries like OpenSSL, libv, and CA certificates ensure security and compatibility. Now for verifying the installation, we write Python version 3.13, and for verifying pip installation, we write pip version, which is 24.3. And for check the installed Django version, we write Python -m Django version, which is 5.15. Troubleshooting tips. Permission errors, always run the Anaconda prompt as administrator. For version conflicts, ensure no conflicting Python installations on your system. For network issues, use a stable internet connection for downloading packages. Summary and next steps. What we achieved: install Python Django required dependencies on your Windows system. Verify that the environment is correctly set up for Django development. Next steps. In the next tutorial, we will create a new Django project and explore its basic structure. Welcome learners. In this tutorial, we will take you through the process of creating your first Django project step by step. By the end, you will First, understand the structure of a Django project. Second, create and configure a new project. Third, run the development server to see your project in action. Step 1. Understanding the Django project structure. When you create a Django project, it includes several important files and folders. Let's break them down. Manage.py, a command line tool for managing your project, for example, running the server, migration, and project folder. For example, full project in my case contains your project's main files. init.py tells Python this folder is a package. Settings.py contains your project's configuration. For example, database settings, installed apps. urls.py manages URL routing for your application. wsgi.py prepares your app for deployment using wsgi, and asgi.py prepares your app for asynchronous communication using ASGI. Step 2. Creating your first project. Follow these steps to create your first Django project. Open your Anaconda prompt or terminal. Ensure your BJ environment is activated. Then run the following command to create a new project called full project 1, for example. Django admin start project full project 1. The project is created. To navigate into your project folder, use cd change directory to full project 1. Step 3. Running the development server. Django includes a built-in server for testing your project locally. Start the server with this command: Python manage.py run server. To open your browser, you can click on this link. Now we can see Django's congratulations page. This means the project is set up correctly. Step 4. Troubleshooting tips. Port already in use. If the default port 8000 is busy, use a different port. For example, Python manage.py run server 8080. Then syntax errors. Double check that you have typed all commands correctly. In summary, created a Django project named full project 1. Run the development server. Verify the setup by viewing the default Django page in your browser. Build your first Django app. Overview. In this tutorial, you will build your first Django app step by step. By the end of this session, you will understand the difference between a Django project and a Django app. Create a Django app using the startup command and explore the folder structure of a Django app. First, what is the difference between a Django project and a Django app? Before diving in, let's understand these two key concepts. Django project. This is the overall container that holds your settings and configurations. A project can have multiple apps. Second, Django app. This is a web application with a specific purpose. Apps are reusable and can be added to different projects. For example, imagine a blogging project. You might have an app for posts, an app for comments, and an app for user accounts. How to create a Django app? Step 1. Open your project folder. Open Anaconda prompt. Conda activate DJ. After we activate Django, we change directory. CD. In my case is C users Azad full project 1. Step 2. Create the app. Use the startup command to create a new app. Type this command, Python manage.py start app pools, for example. It's created. Make sure you are in the correct folder where manage.py is located and match the names exactly, including capitalization. What is inside a Django app? Once the app is created, you will see a new folder named pools. Here is a quick overview of its structure. Admin.py used to register modules for the Django admin site. Apps.py manages app configuration. Modules.py define your app's data structure. Tests.py write tests to ensure your app works correctly. Views.py add the logic for handling user requests. init.py makes the folder as a Python package. And migrations folder tracks database changes. How to link the app to your project? After creating the app, you need to connect it to the project. Here is how. Step 1. Open settings.py. Go to your project folder and find the settings.py file. For example, in Visual Studio Code. We open settings. Step 2. Edit the app. Look for the installed apps list in the file and add your app's name. Step 3. Save the file. Your app is now registered and ready to use. In summary, what you have learned, the difference between a project and an app, how to create an app using Start App, the purpose of key files in an app, and how to link an app to a project. Congratulations, you have built and set up your first Django app. Get ready to edit exciting features in the next session. Mapping views to URLs in Django. Step 1. Understanding Django's URL dispatcher. Django's URL dispatcher connects URLs to views. When a user types a URL, Django searches for a matching pattern in the urls.py file and calls the related view function. This process dynamically generates connect for the web application. Step 2. Writing your first view. A view is a Python function that handles web requests and returns responses such as HTML content, redirects, or file downloads. Follow these steps to create your first view. Open the views.py file in the Pulse app directory. If the file doesn't exist, create a new Python file named views.py inside the Pulse directory and edit the following code to return a simple HTTP response. From Django.http, import HTTP response, div index request, return HTTP response. Welcome to the Pulse project, ready to cast your vote. From Django.http, import HTTP response, div index request, return HTTP response. Welcome to the Pulse project, ready to list your vote and save it. This function index sends back a message when accessed. Mapping views to URLs. Now let's connect our view to a URL so it can be accessed in the browser. Follow these steps. Create a url.py file inside the Pulse directory if it doesn't exist. We name it urls.py. Now we added the following code. From Django.urls import path. From current package import views. URL patterns equal path, comma views.index, name equal index, that connects index view to root URL. From Django URLs import path. From dot current package, import views, URL patterns equal path views dot index name equal index. This setup means that visiting pools will call the index view. Therefore, including pools URLs in the main project URLs. We need to tell Django to recognize our app's URLs by including them in the project's main URLs.py file. Follow these steps. Open the project's main URLs.py file, usually found in project name, for example, pool project slash url.py. Added the following code to include the pools app URLs. From Django.contrib import admin, from Django.urls import path and include, from Django.http import HTTP response redirect, and URL patterns equal path admin admin.site.urls path pools include pools.urls and path empty lambda request HTTP response redirect pools. Now, when a user visits pools, Django will look for matching patterns in pools/urls.py. Step 5. Testing views in the browser. Let's test our setup by running the Django development server. Follow these steps. Open your terminal and run the following commands. Conda activate DJ. Then change the directory cd c users now write python manage.py run server. Now we opened the browser and everything is correct. You can see welcome to the Pulse project, ready to cast your vote. In summary, Django's URL dispatcher connects URL patterns to views. Then views handle web requests and return responses. Then mapping views to URLs requires defining patterns in the urls.py files of both the app and project. Then after setup, you can test your views by running the development server and visiting the mapped URLs. By following these steps, you have successfully mapped your first views to a URL in Django. Hello learners, in this tutorial, we will walk you through the process of setting up a database in Django. Step 1. Understanding Django's default SQLite database. What is SQLite? SQLite is a simple, lightweight, and serverless SQL database engine that comes built with Python. It is Django's default database choice. Why choose SQLite? First, it is easy to use. No need for a separate server. Second, ideal for development. Perfect for small-scale applications. Where is SQLite used in Django? Django is pre-configured to use SQLite by default. The database settings can be found in the full project/settings.py file. Step 2. Configuring database settings. Locate the settings file. Open the full project settings.py file to check or modify the database settings. By default, Django uses the following settings for SQLite. Database equal default, engine, Django db.backends.sqlite3, name base dir /db.sqlite3. Engine specifies the database backend for SQLite, while name defines the location of the database file, which is set to db.sqlite3 in the project's base directory. Step 3. Running migrations. What's migration? Migrations are Django's way of applying changes to the database schema based on your modules. They help create or update tables automatically. To apply migrations and create tables, run the following command. Python manage.py migrate. What happens during migration? Django checks the installed apps list to see which apps require database tables. It creates or updates tables according to your modules. Python manage.py migrate. Step 4. Verifying the database setup. Check database file. After running migrations, ensure that the db.sqlite3 file has been created in the base directory of your project. db.sqlite3 is created. Check tables using Django shell. Run the following command to access the database shell. Python manage.py db shell. Once inside the shell, you can use SQLite commands to inspect the database. For view all tables, we can use .tables. For view table structure, we use pragma table underscore info auth underscore user. To view data from a table, select asterisk from auth underscore user. To exit the database shell, we use exit tables pragma table underscore info auth user ID integer password username and so on. Select from auth user. To exit the database shell, we use exit. Step 5, configuring time zone. To ensure correct daytime operations, set the time zone in pool project /settings.py to your local time. For example, in my case, time zone equal Asia, Baghdad. Asia, Baghdad. And save. In summary, by following these steps, you will be able to understand Django's default SQLite database, configure database settings in settings.py, run migrations to create database tables, and verify the database setup by checking the database file and tables. Hello learners. In this session, we are creating a model for a pool app with a Django. Introduction to Django ORM. Django ORM, Object Relational Mapping, helps us interact with the database using Python instead of SQL. It allows us to define database tables using Python classes, create relationships between tables, and query data easily with Python. Every model we create in Django represents a table in the database. Define models for the pools app. You will create two models, question and choice. Question model stores pool questions, while choice model stores the possible choices for each question. Steps to define models. First, open the models.py inside pools. Second, add the following code from Django.db import models, class question, models.model, question text equal models character field, maximum length 200, publication date equal models.datetime field, date published, class choice, models.model, question equal models.form key, question comma on delete equal models.cascade, and choice text equal models.character field maximum 200, votes equal models.integer field default equal O. Page directory. Now we go to open models.py. From Django.db import models. Create models here. Class question. Models dot model question text equal models dot character field maximum length 200 update equal models dot date time field date published class choice models dot model question equal models dot foreign key question on delete equal models dot cascade choice underscore text equal models dot character field maximum length 200 votes equal modulus dot integer field default equal 0. Then we save it. Making and applying migrations. After defining modulus, we need to create tables in the database using migrations. Steps to create migrations. Open the terminal and run Python manage.py make migrations tools. You can see these outputs. Create model question and create model choice. Now we apply the migrations to update the database. We use Python manage.py migrate. Operations to perform. Apply all migrations, admin, auth, content types, policy sessions, running migrations. Step 4, adding custom methods to models. We can add useful methods to our models to enhance their functionality. Steps to add methods. We open models.py inside policy and update the models. Import datetime from Django.db, import models from Django.utils, import time zone. We already defined questions. Div str self, return self.question text. Div was published recently, self, now equal time zone.now, return now datetime dot time delta days equal 1, was published recently dot admin order field equal pub date, was published recently dot boolean equal true, was published recently dot short description equal published recently, class choice, models.model, question equal models, we defined it, and div str self return self dot choice text. After we updated it, we save the file. str method returns a readable string representation, while was published recently checks if the question was published in the last 24 hours. Step 5, registering models in Django admin. To manage our models in the admin panel, we need to register them. Open inside Pulse admin.py file and added it from Django.contrib import admin, from .models import question and choice, class question admin, admin.model admin, list underscore display equal question text, update was published recently, admin.site.register question and question admin.site register choice. From Django.contrib import admin, from .models import question, comma, choice, question admin.model admin, list display equal question text, update, comma, was published recently, admin.site.register question, comma, question admin.site.register choice, and we save it. This will display was published recently in the admin panel. Step 6, testing the methods. Run the development server by running this code, python manage.py run server. Then open your browser and go to the Django admin panel at this link, python manage.py run server, and we click on this link. Instead of Pulse, we go to admin. Recap: we defined the question and choice models. Then we created and applied migrations to update the database. After that, we added custom methods for additional functionality, and then we registered models in the admin panel. By following these steps, you can effectively manage pool questions and choices in your Django application. Exploring the Django admin interface step-by-step guide. Hello learners. In this lesson, you will learn how to use Django's admin interface to manage your web application's backend easily. The admin interface helps you edit, and delete records, manage users, and more. Step 1, creating a super user. A super user is an admin who can access all features of the Django admin interface. Follow these steps to create a super user. Open your terminal and run activate Django environment, in my case DJ, then change directory, then run python manage.py, create super user, username, for example, my name, email, and we should choose a strong password. Confirm a password. Super user create successfully. Step 2, accessing the admin interface. Start the Django development server by running Python manage.py run server. Open the admin page in your browser. Enter your username and password to log in. Customizing the admin interface. You can customize how the admin panel looks and works by editing the admin.py file in your app. Some customizations include adding new fields to forms, changing how data is displayed, adding search and filtering options. For example, let's customize the admin panel to show the question model from the Pools app. Step 4, registering models in the admin panel. To display models in the admin panel, you need to register them. Follow these steps. Open the admin.py file in your app folder. From Django.contrib, import admin. From .models, import question. Admin.site register question and save. Once registered, the question model will appear in the admin panel for easy data management. In summary, create a super user, set up an admin user to access the admin interface, access the admin panel, open the browser and log in to manage your data, customize the admin, modify the admin interface to suit your needs, and register models. Make your app's models visible in the admin panel. By following these steps, you will be able to manage your Django app efficiently using the admin interface. Adding views in Django, step-by-step guide. Hello learners. In this session, you will learn how to create and link views in Django. Views handle the logic of your web application by processing user requests, interacting with the database, and returning responses like text, JSON, or HTML. Step 1, understanding Django views. Django views are Python functions that process incoming requests, retrieve data from database, and return responses. Step 2, creating views. Follow these steps to create views in Django. Define views in /views.py file. Open views file and add the following functions. From Django.http, import HTTP response. From .models, import question. Define index, request, latest question, underscore list equal question dot objects dot order by, update, last 5, output, comma, join queue dot questions underscore text for queue in latest question list, return HTTP response output. Define details, request, comma, question underscore ID, return HTTP response. If you're looking at question ID, define results, request, comma, question ID, return HTTP response. You are looking at the results of question ID. Finally, define vote, request, comma, question ID, return HTTP response. You are voting on question ID. Define index, define detail, define request, and define vote. After we update it, we should save the changes. Index function displays the latest 5 questions. Detail function shows details for a specific question, while results displays results for a specific question. Vote handles voting for a question. Link views to URLs in pools/urls.py. To access these views in your browser, you need to map them in the URLs. Open the pools/urls.py file and edit the following code. From Django.urls import path, from .import views, URL patterns, you open URLs file inside pools. From Django.url import path, it's already written. From import views, then URL patterns equal, we should update this part, path init question underscore ID views dot detail name equal detail, path init question ID results names equal results, path init question ID vote slash views dot vote name equal vote. After this update, we should save the changes. First path maps to the index view. Second one maps to the details view with the question ID. Third path maps to the results view, while the final path maps to the vote view. Step 3, testing the views. Once we have created the views and linked them to the URLs, test them by following these steps. Start the Django development server by running the function Python manage.py run server. Open your browser and visit the following URLs. Pools in your local host 8000, then pools/1, pools/1/results, pools/1/vote. The question which we added, how do you do? We are looking at question 1. You are looking at results of question 1. We are voting on question 1. In summary, define views, create functions in views.py to handle requests and return responses. Second, map views to URLs. Added URL patterns in url.py to link views to specific pages. Finally, test the views. Run the server and visit the URLs to check if everything works correctly. By following these simple steps, you will be able to create and test views in your Django project easily. Welcome back, learners. Today's topic is creating templates in Django, step-by-step guide. Django templates help separate the design HTML from the backend logic. Let's go through the process of creating and organizing templates step by step. Setting up the templates directory. Step 1, create a templates folder. Inside your Pools app directory, create a folder named templates. We open the folder of our project. Inside Pools, we create new folder. Name it templates. Enter. Step 2, edit a subfolder for your app. We name it Pools. Inside the templates folder, create another folder named Pools. Right click, new folder, name it Pools. Enter. Step 3, create template files. Now create the HTML template files inside the Pools folder. Right click, new file. We name it index.html. Enter. Again, right click, new file. We name it detail.html. Enter. Now, index and detail HTML files created inside pool in the subdirectory templates inside pools inside full project. Now writing the templates. First, index.html homepage. This template displays a list of questions or a message if no questions are available. We write the following code. Opening curly brace, %, if latest _ question underscore list percentage sign and closing curly brace, angle bracket, UL, opening curly brace, percentage sign for, we're writing for loop, for question in latest question list, percentage sign, angle bracket, E bracket, H ref equal, double quote, curly bracket, percentage sign, URL, detail, question dot ID. We close it, and now we open double curly brace, question dot question underscore text space, closing double brace. We close I element for hyperlink and LI element. Now curly brace, percentage sign, int for, else statement, P, no pools are available. Finally, int if statement. This template first checks if there are any questions available. If there are, displays them as a clickable links. Otherwise, it shows a message indicating that no polls are available. Inside index.html, we also added H2 latest question, curly brace, person sign, for question in latest question list. We close it, angle bracket P, question text, opening curly brace, percent sign and empty statement, and we closing it. After that, angle bracket P, no questions available. We close it. And finally, opening curly brace, percenting sign. Next, detail.html, question details page. This template shows a specific question and its choices. Page 1, double brace, question, dot, question, underscore text, closing double brace, then opening UL statement, for choice in question dot choice underscore set dot on, closing curly brace, list statement, double curly brace, choice dot choice underscore text space, and closing brace. Now writing in for statement. After that, we should save the update in the detail.html file. Now updating, we used to use templates. inside tools, we open views from Django dot shortcuts import render from dot modules import question defining index request latest underscore question underscore list equal question dot objects dot order by single quote hyphen pub underscore date 5 return render request comma single quote equals forward slash index dot html comma opening curly brace single quote latest question list latest question list. Now we save these updates. Now updating the detail view. Modify the detail function to render the detail.html template. From Django.shortcuts import get objects or 404 render. From .models import question define detail request comma question underscore id equal get object or 404 error message question comma pk equal question id return render request comma single quote false forward slash detail dot html comma open curly bracket question. After these updates in views.py, we should save it. After we define index and detail, we also define results to display the results of a specific question. Request comma question id question equal get object or 404 question comma pk equal question id return render request false results.html. And after that we define vote request comma question id question equal get object or 404 question comma pk equal question id select underscore choice equal question dot choice underscore set dot filter pk equal request dot post dot get choice dot first. If not select choice return render request comma false details dot html. Question is question and error message you didn't select a choice. For increment the vote and save the choice, select underscore choice dot vote plus equal 1, select underscore choice dot save and return redirect false results comma question underscore id equal question id. Instead of writing fixed URLs, use Django's URL tag in your templates for better flexibility. Now testing your templates. To check if your templates are working correctly, then Python manage.py run server. Best practice. Follow these best practices to keep your project clean and maintainable. First, use get underscore object underscore or underscore 504 to avoid errors when retrieving objects. Second, always use URL Django tags instead of hard-coded links. And organize templates in subdirectories to keep things clear and scalable. In conclusion, by following these steps, you can create well-structured templates that separate design from logic. This helps in making your Django application easier to maintain and scale. Hello learners. In today's session, you will learn implementing generic views. Django provides class-based views, CBVs, as an alternative to function-based views to help organize code and make it more reusable and efficient. Why use CBVs? Because it is less repetitive code, write less code for common tasks, and reusable and organized. You can use inheritance to build new views from existing ones. And it is built-in features. Handle data retrieval, rendering, and pagination easily. What are generic views? Generic views are pre-built CBVs provided by Django for common tasks like displaying lists or details of objects. Why use generic views? Because they are saves time, reduce writing repetitive codes, and handles common tasks like filtering, sorting, and pagination automatically. And to focus on your app logic instead of rewriting code for basic operations. Displaying a list of questions using list view. Let's learn how to use list view to show a list of full questions step by step. Step 1. Define a list view in views.py. We open views.py from Django.views.generic import list view. From .models import question, you should add the class question list view colon model equal question template name equal pools question list dot html context object name equal questions, and we should save it. Step 2, create the template. Create a new HTML file at pools/templates/pools question underscore list dot html. New file. Question list dot html. Enter. We added the following code: h1 pool questions angle bracket ul opening curly bracket percentage sign for question in questions percentage sign close bracket double curly brace question dot question underscore text space and closing brace curly brace percentage sign and for space percentage sign, and we should save it. Step 3, added the URL in urls.py. Added the view to the URL configuration in pools/urls.py. From dot views import question list view URL patterns path question comma question list view dot as view name equal question hyphen list, and we save it. Step 4, view the lists in browser. Run the Django server and visit http 8000 pools/questions. Pools questions, how do you do? Sample question. Displaying a single question using detail view. Now let's use detail view to show details of a single question. Step 1, define a detail view in views.py. From Django.views, generic import list view and detail view. Classes question classes question detail view colon model equal question template name equal pools question detail.html context object name equal question. After this update, we should save it. Step 2, create the template. Create a new file at pools/templates/pools and name it question_detail.html. question_detail.html. Inside it, we write h1 double opening curly brace question dot question underscore text space closing double curly brace angle bracket P published on colon question dot update space and closing double curly brace. Control S to save updates. Step 3, add the URL in urls.py. From Django.url, import path. From .view, import question list view and question title view. Single quote, questions / int colon pk / comma question detail view dot as underscore view comma name equal single quote question hyphen detail. Control S to save it. Step 4, view the details in browser. Tools questions. Number 1. How do you do? Published on 21st January 2025. Tips and best practice. Customizing context variables. Use context underscore object underscore name to set custom variable names in templates. Second, using mixins for extra features. Added authentication easily using mixins like login required mixin and overriding methods for custom behavior. You can filter questions based on conditions by overriding methods like get underscore query set. Key takeaways: class-based views, CBVs, help organize and reuse code efficiently. Generic views like list view and detail view reduce repetitive coding. Using CBVs allows you to focus on app logic instead of writing common tasks from scratch. With just a few lines of code, you can create powerful dynamic views in Django. By following this guide, you can easily start using Django's class-based views in your projects. Welcome back, learners. In today's session, we are working with the forms in Django. First, creating forms for user input. Forms in Django help us collect data from users. In this guide, we will create a simple pool voting form step by step. Steps. First, create a form in the polls/detail.html template. Second, use the post method to submit user choices. Third, added a CSRF token for security. Fourth, display pool choices with radio buttons. We open detail.html file and we write the example code. Form action equal URL plus colon vote question dot id method equal post CSRF token, then field set legend h1 question underscore text closing h1 and legend. After that, if error message paragraph strong error message closing strong and paragraph, and if then for choice in question choice underscore set dot all input type equal radio name equal choice id equal choice for loop dot counter value equal choice id label for choice for loop dot counter choice dot choice underscore text closing label and dr, then in for statement closing field set and input type equal submit value equal vote closing form statement. This form allows users to vote by selecting an option and submitting it securely. Second, handling form submissions. When a user submits the form, we need to process the input and update the vote count. Steps. First, get the selected choice from request.post. Check if a choice was selected. Then update vote count and save. Finally, redirect to the results page. The code example that we added to the views.py inside pools from Django.http import http response redirect from Django.shortcuts import get object or 404 comma render from Django.urls import reserve from .modules import choice and question. Then defining function of vote request comma request id question equal get object or 404 question comma pk equal question underscore id try selected choice equal question dot choice underscore set dot get pk equal request dot post choice except key error comma choice dot does not exist return render request comma pools slash detail dot html comma question colon question comma error message colon you didn't select a choice, then else statement selected underscore choice dot votes plus equal 1 selected underscore choice dot save and return http response redirect reserve pools colon results comma args equal question id. This function handles form submission and ensures only valid inputs are processed. Third, adding validation and error messages. To prevent errors, we check if a user submits the form without selecting a choice. Example code. If error message, P statement, strong error message, then end if statement. If no option is selected, an error message is displayed. Fourth, displaying results. After voting, users see the results of the poll. Example code for displaying results should be added to the results.html inside polls templates. Inside templates polls, we create a new file. We name it results.html. Enter. Then we added h1, opening braces, question underscore text, then closing curly brace and h1, opening ul element for choice in question.choice underscore set dot all, opening li statement choice.choice underscore text hyphen choice.vote vote choice.vote pluralize closing list statement, then int for statement and closing ul statement. Href equal url police colon detail question dot id. Vote again question and closing a element. Control S to save updates inside results.html. This page displays the current vote count and allows users to vote again. Then updating URLs and views. To connect the forms and pages correctly, update urls.py and views.py files. Let's start with the URLs configuration. We update the file to be from Django.url, import path, from .import views, app name equal pools, URL patterns for each index, detail, results, and vote. Then Ctrl S for save the updates. Now we should update views.py. The final version of the views.py inside polls should be from Django.http import http response redirect, from Django.shortcuts import get object or 404 render, from Django.urls import reserve, from .models import choice, question, from Django.views import generic. Then define the function of vote, request, question ID, question equal get object or 404 question, pk equal question ID. Then we have the class of index view, template name equal polls slash input.html, context underscore object underscore name equal latest question underscore list. Define get query self return question dot objects dot order underscore by hyphen publication date colon 5 class detail view model equal question template name equal polls slash detail dot html, then class result view generic detail view model equal question template name equal polls slash results dot html. Control S to save final updates inside views.py. This URL patterns map to different views, and class-based views help organize the code efficiently. Now update the index.html. Instead of detail, we write polls column detail question ID. Then save the updates. Finally, run the Django server. Opening Anaconda prompt, Anaconda, activate bj cd, change directory, change directory to the path of full project 1, enter python manage.py run server, control and click on the link, sample question, and how do you do? Sample question, for example, for answer option 1, vote, we can vote again. Option 2, vote again. Option 1, vote again. Option 1, option 1, 3 votes. Option 2, 1 vote. By following these steps, you can easily create and manage forms in Django for your projects. Let's add a new question with choices to our project using Python shell. Python manage.py shell from tools.models import choice and question. Then to create a question from Django.utils import time zone. U equal question, then question underscore text equal write this tutorial underscore date equal time zone dot now u dot save u dot id question number 3 access model field values via Python attribute u dot question underscore text write this tutorial u dot pub underscore date 23rd January 2025. Now you are creating 5 choices. U dot choice set choice text equal one star. Votes equal 0. Two star. Three star. 4 star. And 5 star. q dot choice set dot all. That's the query set. We created a Django's model with a question and choice. Now we are running server. You see a new question. So our question, write this tutorial. You can vote now, for example, and vote again, and vote again. Vote again. Building a real-world snake game project. Welcome to this session. Today we are going to create a simple but exciting project, a snake game served as a web app using Django. Let's break down step by step. Key goals. Use Django to serve the game as a web app. Second, use HTML, CSS, and JavaScript for browser-based gameplay. Third, use Django views to handle back-end logic and JavaScript to manage the game's front end interactively. Project structure. We have a root directory that includes manage.py, handles project commands like running the server or migrations. db.sqlite3 stores the project database. And we have app directory snake, which includes init.py, admin, apps, migrations, modules, tests, views, URLs, and templates, subfolder snake, and game.html. And we have static subfolder snake, CSS, style CSS, and JS, game.js. Finally, we have project directory that includes settings, configures the project including installed apps and static files, main URLs.py, connects the main URLs to the apps hooks. This structure keeps the front end and back end separate, ensuring the project is easy to manage and extend. Step 1, project setup. Create a Django project. Run the following commands to create your project and navigate into the directory. Open a new Anaconda prompt. Conda. Activate. CJ. Django. Admin. Start. Project. Snake underscore game. The project created. Now change directory to snake game. Now create a Django app. Within the project, create a new app called Snake. Python manage.py startup snake. Now add the snake app to the installed apps list in a settings.py. We added snake app and save it. Step 2, front-end implementation. You will use HTML, CSS, and JavaScript for the game interface and mechanics. Create the template. Inside the Snake app, create a folder structure for templates and static files. Snake, right-click, new folder. We name it templates. Inside templates, new folder, Snake. Now we create a new file, name it game.html. Enter. Inside the Snake app, you also create another folder. We name it static. Enter. Inside static, new folder, Snake. Enter. Inside Snake subfolder, we create new folder. We name it CSS. Inside CSS, we create new file. We name it style.css. Enter. And inside Snake, we create another subfolder. We name it JS. Inside JS, we create a new file. We name it game.js. HTML file. After updating this code, we use Ctrl S to save it. This code creates the game.html template for the Snake game. It loads a static file, CSS, and JS using Django static tag. The HTML structure includes a canvas element where the game is drawn with a fixed 500 x 500 pixel size. The linked CSS file, style.css, styles the game, and the game.js script handles the game logic. The template integrates the necessary CSS and JavaScript files for styling and game functionality, providing a structure to render the game within a canvas. It ensures that the game runs within a styled container with all resources correctly linked through Django's static file management. Now add CSS style. To style the game, inside style.css, we add the style for body, game container, and we save it. This code centers the Snake game's container in the middle of the screen using Flexbox. It removes default margins, sets the body background to a dark blue, and gives the game area a light teal background with a blue border. The fixed 500 and 500 pixel game container is visually distinct and positioned relative for future content placement. Now add JavaScript. Inside game.js, we added the following code. Ctrl S to save the code. This JavaScript code handles the logic of snake game. It uses the HTML5 canvas elements to draw the game, where the snake and foot are placed. The snake moves based on key presses, and the game checks for collisions with the walls or itself, resetting if either occurs. The snake grows when it eats food, and new food is placed randomly. The game loop updates the game state and redraws the canvas every 100 milliseconds, providing continuous gameplay. It also manages user input to control the snake's direction and resets the game on collision. The game loop ensures smooth real-time updates. Step 3. Backend implementation. Starting with the create a view. Edit views.py to render the game. From Django.shortcuts import render. Define game request colon return render request comma snake game.html. We save the update of its code inside the views.py. This code imports the render function from Django's shortcuts model and defines a view called game. The game function takes an HTTP request as an argument and returns the rendered HTML page to be displayed. Add URLs. Create urls.py inside snake directory. Right-click new file. urls.py. Enter. Inside url.py, we added from Django.urls import path, from .import views, URL patterns equal path, single quote, comma, views.game, comma, name equal game, and we save it. Also, we should update urls.py inside snake underscore game. From Django.contrib, import admin. From Django.url, import path, comma, include URL patterns equal path admin, path include snake dot urls. Control S to save it. This code sets URL routing for a snake game in Django. The root URL is mapped to the game view. From views.py, we added static root to the settings.py. Static root equal os.path.joins base underscore directory, comma, static files. Control S to save. Import OS and static root. Step 4. Run the server. First, collect static files. Python manage.py collect static. Yes. Now run the development server. Python manage.py run server. Control, click on the link, and that's it. We can change the speed of the game inside the game.js JavaScript by changing set timeout. For example, from 100, we change it to 150 to be a bit slow. Run server again. Conclusion, we have now built a fully functional snake game using Django. This project demonstrates how Django can serve dynamic web apps and integrate with the front-end technologies. Hello guys, in today's session, we will create a simple Django web app to convert PDF to Word. Step 1. Setting up the Django project. Let's open Anaconda prompt and activate a virtual environment. That helps avoid conflicts between different Python projects. Conda, activate BJ. Now install required packages. Install the necessary libraries for building the web application, including Django, which is already installed for web development, PDF Plumba for extracting text from PDFs, and Python docs for generating Word documents. Pip install PDF Plumba Python docs. Requirement already satisfied. Now let's start a new Django project. Create a new Django project named PDF to Word to serve as the foundation of the web application. Then navigate into the project directory. Django -admin start project PDF to Word. The project now is created. cd change directory to PDF to Word. Let's create a Django app. Inside the project, create an app named Converter to handle the core functionality of the PDF to Word conversion. Python manage.py startup converter. Register the app to ensure Django recognizes the web app. Add converter to the installed apps list in PDF to Word settings.py. Open folder PDF to Word. Inside PDF to Word settings, Ctrl F to search installed apps. Fuel added converter and save. Step 2. Create a form for file upload. Starting with the define a form. In converter /forms.py, define a form that allows users to upload PDF files via the web interface. The form uses Django's forms.file field to handle file inputs. Side converter, right click, new file, we name it forms.py. From Django, import forms, classes, upload PDF form, forms.form, column, PDF file equal forms.file field, label equal double quotation, select PDF file, Ctrl S to save updates. Step 3, implement the conversion logic. Starting with the added conversion logic. In converter views.py, implement the logic to process the uploaded PDF file. The script saves the file temporarily, extracts its text, and generates a Word document. Views.py first handle PDF upload, extract text, and convert it to Word. Starting with the import necessary modules. From Django.shortcuts import render, from Django.http import HTTP response, from .forms import upload PDF form, import PDF Lumba, from docs import document, import OS, import temp file, and import UUID. Then define convert PDF to Word. In this function, if request dot method equal post, check if the request is a post request, then form equal upload form, request dot post, comma request dot files. After that, if form dot is valid, colon, validate the uploaded form, PDF underscore file equal request dot files, bracket PDF underscore file to get the uploaded PDF file. Then create temporary paths for processing. Temp PDF path equal os.path.join temp file.get temp dir, comma ftemp underscore uuid dot uuid4 dot hex closing curly brace, then dot pdf. Output word path equal os.path.join temp file.get temp dir. Then save the uploaded PDF file temporarily. Extract text from the PDF using PDF Lumba. Then create a new Word document. Send the Word document as a response. Clean up temporary PDF file. Do not make errors when the same file uploaded twice. And clean up temporary Word file. Then render the form for file upload. Step 4. Set up URLs. Starting with the configure URLs, define URL pattern in PDF to Word /words.py to route users to the PDF to Word conversion view. Define URL patterns for the application. From Django.urls, import path. From converter, import views. Path, root views dot convert PDF to Word, comma, name equal convert PDF to Word. Control S to save. Step 5, create the HTML template, starting with the design the upload package. Create the converter slash templates slash converter slash upload.html file to provide a simple interface for users to upload PDF file and initiate the conversion process. Side converter app, we create new folder, name it templates, enter. Inside templates, we create a new subfolder. We name it converter, enter. Inside converter, we create a new file. We name it upload.html, enter. Added the following code inside upload.html. Doc type HTML, HTML language equal English, head, the title is PDF to Word converter. Then in the body we have convert PDF to Word. That includes button of submit, then button of convert. Then we save updates in this file. Step 6, run the app. Start with the apply migrations, apply database migrations before running the server to set up necessary configurations. Python, manage.py, make migrations. No changes detected. Start the development server. Run the Django development server to access the application locally. Python, manage.py, run server. Control click on the link. Now we are in the page convert PDF to Word. We have a choose file button and convert button. Choose file. For example, we have PDF sample. Open and we click on convert. It is downloaded to my local computer. That's it, converted from PDF to Word. Let's upload a second PDF. For example, this PDF. Then we click on convert. It's the output of converted from PDF to Word using our Django app. Great job and happy coding. How to publish projects on GitHub, a step-by-step guide. Step 1, install Git via Conda. Open an Conda prompt. If you are using a virtual environment, activate it first. Conda, activate DJ. This activate Conda environment, name it DJ. If you are not using a virtual environment, you can skip this step. Then install Git by running the following command. Conda install C for channel Anaconda Git. This installs Git from the Anaconda repository. In my case, all requested packages are already installed. But if you not installed Git, you should confirm the installation when prompted by press Y to proceed. Step 2, verify installation. After the installation is complete, check if Git is installed correctly by running Git version. My Git version is 2.45.2. So this command, git version, displays the installed Git version if installation was successful. It should return a version number. Step 3, configure Git. After installing Git, configure your user details. Git config global user name, my name. You should write your name. Then Git global user email. This is my email. You should write your email. The username and user email settings are required for Git to associate your commits with your identity. Global term ensures the settings apply to all projects on your system. Step 4, initialize a Git repository. Navigate to your project folder, CD, PDF to Word. This changes the directory to your project folder. You should replace the path with your actual project location. After that, initialize a new Git repository using git init. This creates a new empty Git repository in the project directory. Step 5, create a .ignore file. It's optional but recommended to prevent Git from tracking unnecessary files. So create a .gitignore file using the command echo .gitignore. Then we open .gitignore file, for example, in Visual Studio Code, and edit the following content. The first one ignores compile Python files. PyCatch ignores Python catch files, while db.sqlite3 ignores the SQLite database file. .env ignores environment variable files, while media and static files ignores media and static folders. Step 6, added files to the repository. Now that your repository is initialized, add your project files to Git. Git added that stages all files in the project folder for commit. Step 7, commit the changes. Now commit the files with a message using git commit m initial commit. Commits the added files to the repository. The m flag allows you to add a message. For example, initial commit. One file changed, created mode, git ignore. Step 8, push to GitHub. To push your local project to a GitHub repository, follow these steps. First, create a new repository on GitHub. Go to GitHub and log into your account. Click on the plus and choose New Repository, which is located at the top right corner, and select New Repository. Then enter a repository name. For example, PDF to Word. This name is available. And we choose, for example, repository should be public or private. And added a README file. And this will set main branch as the default branch. We can change the default name in the setting. Create repository. Now link your local repository to GitHub. After creating the repository, GitHub will provide a URL to link your local repository to the remote. Click on the code and copy this link. Now run the following command in your terminal or on the prompt to link your local repository to the GitHub repository. Git remote added origin remote origin already exists. In your case, it should be created. In my case, I deleted it first, then git remote added the origin. After that, git push u flag for upstream origin main. That uploads your local commits to the remote repository. Because the name of my branch is master, we faced the error to push. To solve this, we change the name of our branch from master to main. After that, git push to main branch. Error failed to push. So we pull first git pull origin main. After that, we push it. Because we faced conflicts in readme file, we used git add the readme.md, then git commit resolve merge conflict in readme. Use git push. Then we can go to the link. In conclusion, now your project is successfully tracked with a Git and stored on GitHub. You can continue making changes and pushing updates as needed. Deploy Django project on Render. Hi everyone. In this tutorial, you will go step by step to deploy your Django app on Render. By the end, your project will be live and accessible online. Let's dive in. 1. Prepare your Django app for deployment. Update settings.py. Configure static files. In settings.py, add static URL equal static, and static root equal os.path join base directory and static files. Control S to save. Collect static files by running. Activate virtual environment. Then change directory to my project. After that, Python manage.py, collect static, no input. We need to import OS in settings. "127 static files copied to static files folder." Django doesn't automatically serve static files in production. Static root defines where the collected files will be stored, and collect static gathers all static files into this directory. Then for configure database, if you are using SQLite, it works without modifications, while for PostgreSQL, it needs updates in settings.py. Also, we should create requirements.txt. It should be includes necessary packages for deployment. We create requirements.txt. For example, it includes Django version equal 5.15, unicorn required for running Django on Renda, and some other packages. And create prog file in your project root with the following content: web, unicorn PDF to word.usgi application. This tells Renda how to start the Django application using unicorn. Configure renda.yaml. Create a renda.yaml file to ensure necessary system dependencies are installed. Next step is deploy your Django app on Renda. Starting with the setting up and create a web service. Go to Renda. Click a new web service. Now we connect GitHub repository. Going to our repository. It's connected. A unique name for your web service: PDF to Word, language Python 3, branch main, build command, pip install r requirements.txt. Instance type for hobby projects, we choose free version. Click on added environment variables, secret key, generate value debug, false. Now deploy service. Click on deploy and wait for Renda to build and deploy your app. Once completed, Renda provides a URL to access your project. Filled successfully and uploaded in 32 seconds. Running Unicorn app. Excited with the status 1. Module not found error. No module named. After we updated our files in local project, we should get it. Commit update render.yaml. Now git push origin main. We faced the error no model named app. To solve this problem, we go to settings. We change the start command to be unicorn pdf to word .usgi application. Then we change the start command in the setting. We deploy it. Successful. Is deployed on the render successfully. Running unicorn pdf to word .usgi application. Click on this link. It is deployed but disabled host. To solve this problem, we go to settings. We update our settings. Allowed hosts pdf to word. Control S. Git added again. Update setting. And push origin main. We redeploy our app again. Will be successful. Your service is live. Congratulations. Your app now deployed on the render. And we can choose a file. For example, this PDF file. Open. After that, we convert it to Word. Let's convert to Word with the unique ID. This is the Word which is converted from the PDF using our live application website. Good luck and happy coding.